Thank you very much, James. And I'm excited to talk a bit about how BioDAOs could revolutionize kind of scientific innovation. I'm curious, maybe like for a check of the audience, like who of you deeply already knows about BioDAO and how it functions? Okay, that's actually most people. So I'll try to get deep and avoid more introductory material. I think from a very high level, I want to start on some of the problems in science, potential solutions that DeSci offers, but then really also BioDAO specifically, and then go into VitaDAO and briefly touch on HairDAO as two examples of like a working model of BioDAOs in action and how they can solve some of the problems we have currently in science, and then also touch on some future outlook with wishes, but also like some visions for how the space could evolve. So, like, I wanted to start off basically more with like the core reason, of course, for advancing science. I think is because it's really fundamental to human progress more broadly. Like, I really like this chart on the right or on the left, where I think basically one of the originators of this progress, of basically human progress and well-being, I think really has to do with science and the scientific method, which of course emerged really and really thrived, I think, throughout the last 200-300 years especially, and led to this exponential progress. And I think there's also a lot of problems we have with science and kind of as our engine of human progress that we need to fix. So there's, I think, 4 interesting categories of problems. I think one, of course, is centered around funding problems, mainly, of course, that it's very centralized funding and very competitive and kind of unfairly distributed, for example, predominantly to fairly old people that already received funding before. And a lot of scientists would, for example, change the topics of their research if the funding was not a concern. And then, of course, scientists spend also like way too much time applying for it. I think then on the more like replication side of things, the big problem is that like a lot of science is not reproducible, and we don't know which science is not reproducible. And there's often no negative data results like reported. And of course, like a lot of things, like I think the best example was Alzheimer's recently, is built on very shaky foundations where it, for example, turned out that the foundational assumption was wrong and like basically faked science. And I think that's a huge problem. Because basically there was like tens of billions wasted on Alzheimer's research that we shouldn't have done if there wouldn't have been this like faked research that it basically relied on. Then I think like also around competition, there's like a lot of perverse incentives, and the life of a young academic is incredibly stressful, but also severely kind of underpaid and like without really ownership in the scientific outcomes, and kind of like publish or perish culture. And I think an interesting statistic, for example, is that like there's less than 2% of the NIH funding goes to under 35-year-olds, which I think shows part of also the problem. And then on the communication side, I think, of course, a lot of science is paywalled. It's not accessible to the majority of humans, even though they paid with their tax dollars for the research, I think, which is also a huge problem. And thus, it's really out of reach with the human population, but also very hard to access. Even if you have a paper, it's like really not made for like broad consumption, let's say. So I think dissemination, peer review, and access are quite broken. And I think a lot of these problems stem from centralization and could be solved by decentralization. So I'll go into some of the side-by-side comparisons, but I think comparing kind of like TradSci against DeSci, and then like with the example of BioDAOs more specifically, in a BioDAO model and the DeSci model, the distribution kind of funds is more determined by the public and community using mechanisms such as DAOs, in the case of BioDAOs, or choreographic donations and other experiments and mechanisms to try to improve on what's broken currently with funding and to add an alternative to it. And of course, what I think is actually one of the biggest pluses, especially in BioDAOs, it's made quite transparently. Like in VitaDAO, you can go to the forum, see the research proposals being discussed, people vote on them, they ask questions, So it's much more transparent than like all of this being hidden behind committees and very intransparent decision making. And then of course, like I think on the collaboration side, it's much more collaborative by nature, especially with peers and that collaborate all over the globe. And on the laboratory and infrastructure side, with tools like LabDAO and others, it's possible to share the laboratory infrastructure and services much more easily. And on the publishing side, I think also we have new models for publishing that at the core use Web3 primitives like decentralized storage or identity and other aspects to kind of rethink publishing and some of the problems in publishing. And connected to that, of course, is also peer review, kind of getting earning tokens and reputation for peer reviewing work. And then last but not least, connected to funding is the IP that basically in this new model, the scientists can own the IP, the collective advancing the research owns the IP, and also can license it on more transparent terms. And I think the biggest one is ultimately how I view DeSci as almost applied meta science. And for those of you that don't know meta science, it's kind of like the science of science, like using the scientific method to study what's broken with science and trying to fix it with novel experiments. And I think decentralized science is kind of like a playground to try out different experiments on all these different aspects, like from funding, collaboration, to publishing and other aspects. And I think, of course, I think DeSci doesn't have perfectly figured out all the right solutions for these problems, but it's like a potential to experiment with novel mechanisms to land on potentially better mechanisms. And I think what I want to go into is basically the examples of some of the DAOs, like VitaDAO or HairDAO, that fix some of these problems concretely today and how they do it. And I want to open this with this question of like, what if science is decentralized through BioDAOs and how this looks in practice. So like broadly, I think the why of BioDAOs is really to enable a collective through decentralized decision making to advance and increase innovation. And of course, in VitaDAO's case, for example, in longevity, and make it really accessible to everyone. And I think what it constitutes is really like a online native, truly global organization that can, like across borders and with way lower barriers to entry, advance science and really allow for like distributed governance and resource allocation and research prioritization with, for example, road mapping. And then by really enabling scientists and communities to form, raise funding, run experiments, prioritize the research, share data, and distribute insights in a more open way. And I think really to underline some of the key aspects, I think what makes them so important is that at the core they're really focused on being constituted out of patients and enthusiasts that follow a specific mission. Like for example, in VitaDAO's case, everyone in the community will suffer from age-related diseases, and thus kind of like it's both like a patient and I would say also enthusiast, because they're willing to spend their time or money in this community. And I think as another aspect, I think the benefit is that it's truly like networked science, a bit like Michael Nielsen lays out as like a more novel form of like scientific collaboration, where it's possible to basically have the advantages of a network instead of like siloed individuals doing science in a very like open internet first research organization. And I think I touch on this for the future outlook. I think it's actually quite important structurally that it's internet first and internet native. I think like our current research ecosystem is physical first and very much not digital native. And I think thus like we'll face problems with like a transition into the like future age, which will I think look much more autonomous and potentially also involve, of course, AI in many aspects. And I think that will be very hard as a transition for the more physical, old TradSci world. Yeah, so like I described this before, that kind of like I see DeSci almost like as an applied meta science playground, trying out new experiments to really come up with potential better solutions. And I want to go into some of the examples in VitaDAO's case where there's, I think, like a range of experiments even beyond IP that I think showcase some of the things that like a traditional science organization or funding body is usually not doing. So at a glance, like you might know kind of like some of these stats already from, and Paolo will speak also afterwards more about BioDAO. So I don't want to touch on it too much, but I think the interesting one is almost on these verticals, because I think a lot of people think that BioDAO is like just funding science, but and just through IP NFTs, but I think there's a lot more to it that actually I think strengthens the network and actually even increases the likelihood that like the IP it funds, the spinouts it creates are valuable. So of course on the funding side, which is the heart of it, it's funding translational research, but it also, for example, we did like experiments on like retroactive public goods funding, on public goods funding through quadratic donations with Vitalik and Gitcoin, for example. But there's also now an increasing amount, for example, of experiments on the publishing and peer review side with the overlay journal called Longevist and a peer review kind of program called Longevity Review, which actually attracted most of the leading scientists in longevity. And already I think has put out like the second journal. And then there's experiments, for example, even on physical manifestations like a network state with, for example, this experiment called Susalu, but then also now more experiments like this coming up. One is called Vitalia and Prospera, and there's actually a lot of ongoing conversations with kind of a lot of the network states, basically helping them with advice on their health program and on the longevity side to almost like enable the broader BioDAO community to access different longevity native pop-up cities or longer term cities, which I think is actually quite crucial to people. It's like this community of scientists at the frontier, of also enthusiasts at the frontier, trying out new things. And then there's a range of, I think, also other experiments, like from prizes to fellowships to hackathons and a bunch of other experiments. Like there's a longevity AI effort. And I think what it just shows is that it's almost like the range of initiatives touching on almost every scientific vertical. And I'll also briefly touch on HERDA, which some of you probably already heard from, that like they, I think, are an interesting example to even expand on some of these experiments and do also different experiments. So I think if you look at BioDAOs as kind of like a new scientific innovation model, like it's of course very focused to the therapeutic area and to like the efforts need to make sense within that area. So I think in that case for longevity, and for hair DAO, of course it looks different because it's hair loss. But I think what's interesting is almost like the range of these experiments and getting quite quick feedback loops and iterating on these experiments in real time and trying to fix the different problems that we have currently in science on multiple fronts, not just on, for example, the funding of science, but also on a lot of other aspects. So I don't want to dwell on this too long because Paolo will speak about BioDAO, but these are just examples of the journal and the peer review page, which, for example, is like happening completely in the open, incentivized by tokens, completely open access and freely accessible. So if you remember kind of the problems I touched on for publishing, I think this is a good shot in the direction of solving it. And for example, it's using also native DeSci publishing tools like DeSci Labs. So it's kind of like eating our own dog food with some of the DeSci publishing solutions. Then this was the example of the longevity network state and some of the other experiments. And that's like 1.5 or 2 years in. I think there's, of course, just like the start of like a bunch of other experiments that I think will be quite interesting. And I think really the power is that all of this strengthens the network. Like ultimately, through the quadratic donation round, we funded over 50 research projects and even funded some like impetus grants that in turn funded 100 research projects. So there's really like, I think, a surface area that is quite huge in terms of like people it affects and also the impact it potentially creates. Also on, for example, the fellowship side and other aspects. And in Herda's example, I think what's quite interesting, because you can do so much stuff directly with hair loss. I think there's a lot of like citizen science, for example, in Herda of people just trying out things and sharing what works and what doesn't, which connects to their patient portal. I think they do really interesting things around getting people really involved on like gamification incentives, like they mentioned with the Ready Hair Player 1, where they incentivize people sharing targets, where basically people get a reputation score for really helping drive and advance research, which I think is really interesting. And then really it's like a direct-to-consumer community where like the community wants to access the treatments they develop. And then I think ultimately also important, I think they have immaculate vibes and memes, which I think like science lacks. Like it's often very dry and serious, and I think BioDAO is a great example of making it very like light and fun. And those are just some of the examples, like on their research portal, and also, of course, really already having like a pretty advanced research project with the highest cited, like most popular scientist in the world on hair loss. I think really shows that this actually also translates into actual scientific progress and discoveries. And then I just want to briefly touch on more like the future outlook, because I think to an extent, of course, this is still quite early and experimental, and I think lots of things are still to figure out and improve. But I think fundamentally, when I think about like where could science end up in like 5, 10, 20 years, I think really like traditional science is like massively underprepared for it. And I think really will struggle to stay relevant like in 10, 20 years. And I think you need internet native scientific organizations and like as many smart people as possible, including computer scientists, including people that like are impossible to recruit into academic organizations to stay relevant and contribute to scientific advancements. And I think we see this with things like DeepMind, for example, driving really huge scientific progress, while like the academic community didn't really crack like protein folding as well as like a team of like 5 people there did. And I think one connected to that is really that I think we'll switch to increasingly AI-driven closed-loop R&D, which basically means a system where artificial intelligence agents propose an experiment, potentially run the experiment, evaluate the experiment, and learn from the experiment to devise a new experiment or to figure out like a solution to a disease. And I think the interesting thing is like a DAO, I think fundamentally is perfectly set out to be a playground for that, because ultimately you could have like an AI agent sourcing research, evaluating it, funding it, even devising experiments for a contract research organization or cloud lab, executing it. And I think what we could see in the near future is, for example, you could imagine like in a community to have different agents that propose experiments or run experiments and get paid for it and compete. And ultimately, I think that really enables like a very like AI native driven R&D organization where still humans are in the loop, and it's still understandable how the decision making is made, and you could delegate to an AI to vote on your behalf. And I think that will increasingly look like quite possible. Like we already have the first like GPT generated like research evaluations with actually quite valuable questions asked to the researcher where they respond back to it, and I think those things start to make sense. And I think especially in like 10 years it will look quite obvious that it will be like the superior way to do a lot of different functions that are currently done by humans. Then I think fundamentally DeSci is really upgrading almost like the scientific method and stack, and really like with this frame of like applied meta science is much more actively iterating and working on science versus just like within science, and within a broken science system it's trying to actively improve like the scientific method and kind of like tool stack. And I think one benefit is it's truly global and enables truly autonomous and decentralized R&D, which I think will also become increasingly important. I think which is quite important almost like from a mission, because I think right now you have like less than 0.1% of humans being involved in the scientific process. Like they're neither involved in funding it nor in contributing to it. And I think the potential is that like a much bigger surface area of humans could get involved in science. And then I think fundamentally in also example like BioDAO and HairDAO, patients and researcher communities can get involved to govern their cures and also access to medications and contribute in different ways with like very different touch points. I think the vision is a bit also like that it becomes as easy to do science as it is to log into a website. Like fundamentally, I think there's a lot of ways where like a lot of people could get involved in science. Another, I think, important aspect is making sure that actually it becomes profitable to an extent, still to become like a scientist that really contributes to innovations, which I think is currently right now decoupled. Like there are sometimes scientists that do the research that lead to billion-dollar drugs, and they are completely disintermediated and make no money in this process, which I think is fundamentally broken if you compare it with startups, for example, where, of course, the founding team is more fairly compensated. I think it's also a vision where like science decouples to an extent from like legacy institutions that have like broken incentives and a lot of problems, as I pointed out earlier. And to close off, maybe like as a call to action more, of course, many of you are already involved, but I think important is kind of like to actually get involved and try to also improve these communities or get funded as a researcher or fund research that you're excited about. And then there's, I think, a lot of touch points from referring research to other aspects that I think a lot of people can get involved in. And that's about it. So you can scan kind of this QR code, which is a link tree with like a bunch of touch points. Thank you very much.